My name's Sam. I've just finished my third year studying Earth Sciences at University College at Oxford. Earth Sciences is the application of maths, physics and chemistry, biology and geology to understanding how the Earth works on all sorts of scales from atomic to planetary. This book is called Colliding Continents. It's by Mike Searle, who's going to be my supervisor next year. We're here in Mike's office now. What I really like about the book is the way that it gives me some context to these mountains which are so evocative, so spectacular. It kind of explains how they came to be. Last summer I spent 6 weeks field mapping in northwest Scotland. The book's been a useful accompaniment to that because there are many parallels really between the area that I was looking at in the Himalayas. I'm particularly interested in relating the landscapes that we can see today to the way in which they formed, and using science and really unravelling that puzzle, because it is a puzzle. This is a sample from the summit of Everest, and remarkably the summit cap of Everest is formed from an Ordovician limestone which originated in a shallow marine environment and now forms the highest point on Earth. But if we go down section, we suddenly come into high-grade rocks from mid-crustal depths and that experience extremely high temperatures. So the contrast between these two rocks and their current position tells us about the processes of mountain building. In Mike's book, he explains a model of how these rocks came to their current position. The model is that these high-grade rocks, which experience very high temperatures, have been extruded out of the mountain belt in a process called channel flow, much like jam could be squeezed out between two slices of bread. The juxtaposition of these two different rock types on Everest tells us something new about mountain building. Traditionally, it's been thought that mountain building just occurs through fold and thrust belt tectonics, but we've learnt here through the channel flow hypothesis that Mike elucidates in his book that there's more to mountain building than just that. What a field geologist really wants to do when they find a great sample on a mountainside is take it back to the lab and get a thin section cut. Once you've got a thin section, you can stick it under the petrographic microscope and have a look. So I think what really stands Earth Sciences apart from purer sciences is the way that you can build real stories through the accumulation of lots of hard work, essentially. But it doesn't come quite in the same way that maths comes to a mathematician. You know, this requires on-the-ground work and laboratory experiments and building up a picture, building up a story. Colliding Continents has allowed me to see the process of building up the pieces of the puzzle and fitting them together over a regional scale and a temporal scale, which has been inspiring for someone like me who I'm going to be working on my own project soon, and it's great to see how they can mesh together and form something larger.